All right, welcome back to the deep dive. Today we're
Hey there. Want to share your thoughts on this?
Hey, can we just go through this paper quickly and make the key points for the main takeaway? We only have about 10 minutes around. Sorry to interrupt.
Hey there, no worries at all about interrupting.
Absolutely. Happy to shift gears for you.
So this PLADIS paper, right? The core idea.
Dot Hill about making the attention part of AI image generators.
Dot specifically the bit that links your text to the picture.
Dot more selective or sparse.
Okay, let's unpack this sparsity thing.
Instead of the AI looking at every single possible connection,
Xiaol.x focuses on only the most important ones.
think of it like highlighting the key words in a sentence.
Here's where it gets really interesting.
This idea of sparse attention actually helps the AI.
Does that deal with the initial randomness, the noise?
That's in the image generation process.
So what does this all mean for the final image?
Better quality images that match your text prompt more accurately.
And the cool part of...
It doesn't need any extra training or slow things down.
So the main takeaway is...
PLADIS is a smart and efficient way to boost AI image generation.
it's about being more precise with attention.
Exactly. Did that hit the key points for you?
Well, these systems that create these images
Mm-hmm.
are called diffusion models.
Exactly. That's the magic of diffusion models.
It is. It's wild. And to make sure the image matches your text.
Guidance techniques?
Yeah, guidance techniques, exactly.
Oh, for sure. CFG is a popular one.
But, as with anything, there's always room for improvement, right?
Always pushing the boundaries.
So that's what we're diving into today.
PLADIS.
Yeah, PLADIS. It's a new method to make diffusion models even better.
And doing it in a really clever way.
Yeah, and the really cool part,
Oh, huge time saver.
big time. And it doesn't slow down the image generation either.
Very efficient, yeah.
So before we jump into the how,
Right, context is key.
what are the problems with existing guidance methods?
Well, a lot of them are based on what works, not necessarily why.
Oh, interesting.
Yeah, the paper calls them heuristic approaches.
Like they tweak things, and if it makes the images better, they go with it.
Yeah, pretty much.
But they don't always know exactly why it works.
That's right.
So that's one problem. And
Right.
what about the computational side of things?
Right, so a lot of these methods need a lot of extra work during generation.
More computing power, you mean?
Yeah, they might need to run the model multiple times,
Oh, I see.
especially if you're working with limited resources.
Makes sense.
Plus, a lot of these methods were developed before the really fast models.
Oh, yeah, those are the ones that are way faster, right?
Yeah, they're streamlined for speed.
But the old guidance methods don't always work so well with them.
Right, they can actually negate the speed advantage.
Oh, that's a bummer.
It is, which is why PLADIS is so interesting.
Got it.
So it's not just about making the images better.
So PLADIS is like a more elegant solution.
Exactly, more academically sound, more targeted.
Cool, I like it.
And from an academic point of view,
Okay, so spill the beans. What's the big secret sauce here?
so it all comes down to this thing called attention.
Okay, attention. I've heard that word a lot.
Yeah, it's a core concept.
In this case, the input being the text prompt, right?
Yeah, and the image features as it's being generated.
Got it.
Now, PLADIS specifically focuses on cross-attention.
So it's like figuring out which words relate to which parts.
Exactly.
So what does PLADIS do with this cross-attention?
Well, here's the surprising part. It makes it sparse.
Sparse, what does that mean?
It means the model doesn't look at every single possible connection.
Like every word connected to every pixel?
Yeah, kind of like that.
That seems like a lot to keep track of.
It is, and that's the thing. With PLADIS, it actually ignores a lot of those.
It ignores them.
Yeah, it focuses only on the most important ones.
Huh. You'd think considering all the connections would be better, right?
You'd think so, intuitively, but that's not always the case.
So how does it decide which connections to ignore?
Good question. So there are two types of attention, dense and sparse.
Okay, dense and sparse. Lay it on me.
So dense attention is the standard way,
Wow, okay, dense indeed.
but sparse attention, which PLADIS uses, is different.
How so?
It uses this function called entmax.
Alpha at max. Okay.
Yeah, and this function forces a lot of those weights to be zero.
So those connections are basically ignored.
Exactly. The model only focuses on the strongest weights.
And there's this alpha parameter you mentioned.
Yeah, alpha controls how sparse the attention is.
Oh, so you can adjust how selective the model is.
Right, you can fine-tune it.
That's pretty cool, but why does the sparsity thing work?
Now, this is where it gets really academically interesting.
I'm all ears.
This sparsity idea comes from hot field networks.
Hot field networks? Never heard of them.
They're a type of neural network good at remembering patterns.
So how do they relate to decision models?
Well, there's a connection between the attention mechanism.
Like they both involve figuring out what's relevant.
Exactly.
And what's special about these Hopfield networks?
Specifically, there's research on sparse Hopfield networks.
Sparse, there's that word again.
Yeah, so in these networks, they intentionally make some connections zero.
So they're ignoring some connections too.
And they found that these sparse networks are more robust to noise.
Robust to noise, what does that mean?
It means they can still retrieve the correct information.
Oh, I see.
And this is important for diffusion models because...
Oh, right, that random noise we talked about at the beginning.
Yeah, so the idea is that by making the attention sparse.
Exactly, it can focus on the important connections.
Yeah, kind of like that.
Clever.
And the PLADIS paper actually provides some theoretical results.
Oh, so they're explaining why it works.
Exactly, they're providing a mathematical foundation for it.
Nice, that's always good to see.
Yeah, it gives more weight to their claims.
So PLADIS isn't just replacing the regular attention.
You're right, it's a bit more nuanced than that.
Fill me in.
They calculate both the regular dense attention.
They do both.
Yeah, and then they combine them using a scaling factor, lambda.
Lambda, okay, what does this lambda do?
It basically controls how much influence the sparse attention has.
So if lambda is low, it's mostly dense, and if it's high, it's more sparse.
Exactly.
So it's like a slider controlling the balance.
Yeah, a nice way to think about it.
Clever, so they can fine-tune how much sparsity they want.
And through their experiments, they found the sweet spot.
So they figured out the best settings for different situations.
Right, to get the best image quality.
Okay, so we've talked about the theory, but what does this mean in practice?
Well, the key thing is that PLADIS doesn't require any extra training.
That's a big time saver, like we said before.
Yeah, and it doesn't add much computational overhead either.
So it's not slowing down the image generation.
Right, which means it's perfect for the fast guidance-distilled models.
The ones that are already super efficient.
Good.
So you can basically take these speedy models and make them even better.
And that's something a lot of older methods couldn't do.
They'd either slow things down or wouldn't work as well.
Right, so PLADIS is kind of a game changer.
So it's not just a theoretical novelty.
Absolutely, and the paper shows this with lots of results.
Okay, give me the highlights. What kind of improvements did they see?
Well, they used metrics like clip score.
So higher clip score means the image is more accurate.
Yeah, and they saw significant improvements there.
Nice.
They also used FID, which measures the overall quality.
And how did PLADIS do there?
Again, improvements, the images were rated as higher quality.
Impressive, but those are just numbers.
Yeah, they did human studies too.
And the verdict.
People consistently preferred the PLADIS images.
That's the real test, right?
Absolutely, and the paper even has visual examples.
I'll have to check those out.
You should, they're pretty convincing.
And you mentioned they experimented with alpha and lambda.
Right, they wanted to find the sweet spot.
And what did they learn?
They found that a balanced level of sparsity worked best.
So ignoring some connections is good, but ignoring too many is bad.
Yeah, it's all about finding the right balance.
Makes sense.
And for lambda, they found an optimal range too.
So there's a sweet spot for how much influence Spark's attention should have.
Right, not too weak, not too strong.
Goldilocks zone.
Haha, exactly.
And is this PLADIS thing only good for one specific model?
Well, they tested it on several different models.
Oh, so they branched out.
Yeah, they tried it with Stable Diffusion 1.5 and even Santa.
And it worked well with all of them.
Yeah, they saw consistent improvements across the board.
So it's not tied to one specific architecture.
Right, it seems to be a more general principle.
That's really promising.
It is. It suggests that sparse attention could be a powerful tool.
And going back to the theoretical side?
It's all about grounding the results in theory.
Right, explaining the why behind the what.
Exactly, by connecting PLADIS to the noise robustness.
It's like adding scientific rigor.
And they even come up with a new theoretical result.
So it's not just a hack, it's based on solid principles.
Exactly.
That's always good to see in research.
It makes the findings more convincing.
Speaking of future research, what are some limitations of PLADIS?
Well, one thing they mentioned is they haven't tested it on the very latest models yet.
Like the really complex ones?
Yeah, like Stable Diffusion 3.
So it's possible PLADIS might need some adjustments?
It's possible more research is needed.
And they've only focused on image generation so far, right?
That's right, but they suggested it could be useful for other tasks.
Like, what else?
Well, anything that involves attention, like video generation,
Oh yeah, that's a hot topic right now.
or even natural language processing.
That's interesting. So this could have implications beyond just images.
Potentially, yeah, it's an exciting avenue.
Cool, so let's wrap things up. What's the big takeaway?
Okay, the main thing is PLADIS is a clever way to improve AI image generation.
It's all about making the attention mechanism more selective.
Right, and this leads to better images without extra training or slowing down.
And it works especially well with the super efficient models.
Exactly, so it's a big step forward.
So for everyone listening, expect even more amazing AI images in the future.
Yeah, and it's all thanks to a deeper understanding.
That's the key, isn't it? Understanding how the AI thinks.
And it leads to a really interesting question, right?
Oh, what's that?
Could this idea of sparsity be a general principle for improving AI?
Not just images, but other tasks as well.
Exactly. Could this lead to better and more efficient AI across the board?
That's a great question to ponder.
It is, and if you're interested, definitely check out the PLADIS paper.
Yeah, it's quite a title, but worth the read.
And if you're really into it, dive deeper into sparse attention and hot flow networks.
Yeah, there's a whole world of fascinating stuff out there.
It's an exciting time to be following AI, that's for sure.
Thanks for joining us on this deep dive. We'll see you next time.
Until then, keep exploring.